Hello class, we're about to start section 2.1, the addition property of equality. Okay, we have objective 1, identify linear equations in one variable. A linear equation in one variable is an equation that can be written in the form ax plus b is equal to 0. Now, we want to list our examples, which I took the liberty of typing here, of examples of linear equations in one variable. You notice we have 5x plus 6 equals 9, 6y minus 5 equals 12, and y is equal to 7. And yes, you can have a variable by itself just equal to a number, and that would be a linear equation in one variable. And then now we list examples that are not linear equations in one variable. And if you notice here, this has more than one variable, or you had a variable taken to an exponent besides 1. Okay, now we solve an equation by finding all of its solutions. Now, the goal of solving a linear equation is to get the variable by itself. Example, if we add 2x is equal to 12. We need to get the x by itself. So the first thing we would do is see what's connected to the variable. This 2 is connected by multiplication, so we take the opposite operation, which is division. So we'll divide each side by 2, and these 2's will simplify out and leave x, and that equals to 12 divided by 2 is 6. We had a variable by itself, so this is our final answer. Now we could try another problem. We could take x plus 5 is equal to 7. We could subtract 5 on both sides, because remember, we're trying to get the variable by itself. We bring down our x. 5 minus 5, we know they would simplify out to 0, and that equals 7 minus 5, which is 2. The variable is by itself. Our final answer is x equals 2. Now we have objective 2. Use the addition property of equality to solve equations. The method for solving a linear equation is to follow one of the most basic laws of algebra. Whatever you do to one side of an equation, you must do to the other side. So just like up here, we divided the left side by 2, we divide the right side by 2. And the same thing here, we subtracted 5 on both sides of the equation. So that is, I usually call it the golden rule of algebra. Now, we have the addition property of equality. Now, it says if a and b are expressions and c is a number, then the equation a equals b and blank are equivalent. Now this right here, I should not have had a times c equals b times c, even though that is correct. But since this is the addition property of equality, I should have put a plus c is equal to b plus c. Now that's because since a and b is equal to each other, if you add the same number to both sides, it's still going to be equal to each other. That is, we can, and all of these statements are to multiply, subtract, or divide, but we're really looking for addition. That is, we can add to each side of an equation without changing the solution. Because remember, we're dealing with the addition property of equality. Okay, now, we scroll down here to example 1. We have x plus 8 is equal to 2. We need to get this x by itself. So the first thing we need to get rid of is what's connected to the x on the left side. This 8 is connected by addition. So we're going to subtract 8 on both sides of the equal sign. So we'll bring down our x. Our 8's will simplify out to 0. And that's equal. 2 minus 8 is negative 6. So our final answer here is x is negative 6. Now we go here to b. We have 4 is equal to m minus 7. So what we need to do is get the variable by itself. We will add 7 to both sides. So 4 plus 7 is 11. It equals 2. We'll bring down the n, and these 7's will simplify out. Now, we scroll down here to the next page. Now we look here at c. We have x minus 0.24 is equal to a negative 5.18. Since this minus 0.24 is subtracted from x, we will add 0.24 to both sides to get the x by itself. Now we will have x, these 0.24s will simplify out. And now we have a negative 5.18 plus 0.24. We know that this number is furthest away from 0, so we know our answer is going to be negative. And we can go off to the side here and take 5.18 minus 0.24. 8 minus 4 is 4. We know we cannot take 2 from 1, so we'll borrow 1 from this 5 and make it a 4, and this 1 will be an 11. 11 minus 2 is 9. Bring down your decimal, and 4 minus 0 is 4. So it'll be a negative 4.94. And that will be your final answer. Now we go here to D. Now we're dealing with fractions. We have 1/3 plus x is equal to a negative 3/4. Now remember, we want this x by itself. So first thing we should do is get rid of this positive 1/3. So we'll subtract 1/3 on both sides of the equal sign. Now these 1/3 will simplify out and leave you x. And is equal to, you got a negative 3/4 and a negative 1/3. Since they have the same sign, you will add them together and carry the sign. So we know our final answer is going to be negative. But there's a little problem here. We have unlike denominators, so we have to find a common denominator. So we could take 3/4, since we know our final answer is going to be negative, we could just write these as positives. 3/4 plus 1/3. The common denominator of 4 and 3 is 12. Now we have to find our new numerator. And what we could do is we could take the new denominator divided by the old denominator. 12 divided by 4 is 3. So we'll multiply this numerator and denominator by 3. And then here 12 divided by 3 is 4. We'll multiply the numerator and denominator by 4. 3 times 3 is 9. 3 times 4 is 12. 1 times 4 is 4. And 3 times 4 is 12. Now we will add this. This would be 9 plus 4 is 13, and that's over 12. And we could leave this because this is simplified, and we were not asked to write this as a mixed number. So it'll be a negative 13 over 12. Okay, now we scroll down here to E. Now we first need to combine like terms on both sides and then go and solve to get the variable by itself. 8y minus 7y. 8y minus 7y would just leave y. 7 minus 10 would give a minus 3. And it equals to 6 plus 4 is 10. Now, to get y by itself, we need to add 3 on both sides. And you will have y, these 3's will simplify out, is equal to 13. And that is your final answer. Now we go over here to F. We do the same thing. We need to combine like terms. Now on the left side, 4x and 2 are not like terms, so we would just leave it as is. Now over here, on the right side, we need to do the distributive property. So we'll do 3 times x, which is 3x, and 3 times a minus 6 is minus 18, and then plus 8. So we have 4x plus 2 is equal to 3x. Negative 18 plus 8 will give a minus 10. Now we need to get all the x's on one side and all the numbers on the other side. So what we could do first is subtract 3x on both sides. Because remember, we need to take the opposite of this positive 3x. And 4x minus 3x is 1x, or you could just write x. Plus 2 is equal to, these 3x's will simplify out, and you'll bring down to negative 10. Now we need to get the x by itself, so we'll take the opposite of a plus 2, which is minus 2. And we'll subtract 2 on both sides, so we will have x. These 2's would simplify out, and it equals to negative 10 minus 2, which is a negative 12. And that is your final answer. Now we scroll down here to example 2. It says solve applied problems using formulas. There is a relationship between the number of words in a child's vocabulary V and the child's age A in months for the ages between 15 and 50 months inclusive. This relationship can be modeled by the formula V plus 900 is equal to 60A. Use the formula to find the number of words in a child's vocabulary at the age of 24 months. Now remember, V stands for the vocabulary. We don't know our vocabulary. Well, let's just write the formula. V plus 900 is equal to 60A. Now, we don't know what V is equal to. That's what we're solving for. So we have V plus 900 is equal to 60 times. Now, A is represented in months for the child's age, and we're told it's 24 months. So we'll take 60 times 24. Now, we could go off to the side and take 60 times 24. 4 times 0 is 0. 4 times 6 is 24. Bring down our 0 here. 2 times 0 is 0, and 2 times 6 is 12. Now, this would give us 1,440. So we have V plus 900 is equal to 1,440. Now, we need to get V by itself, so we will subtract 900 on both sides of the equation. So now we will have V is equal to, because these 900s will simplify out, 1440 minus 900. We can go off to the side here. So 0 minus 0 is 0. 4 minus 0 is 4. We cannot subtract 9 from 4, so we'll borrow 1 from this 1. That'll be 0, and this 4 will become 14. 14 minus 9 is 5. So this will give you 540. So your answer here would be, it says, find the number of words in a child's vocabulary at the age of 24 months. So what you would do is you would say that a child at 24 months should have a vocabulary of at least 540 words. And that would be your final answer.